Welcome back. Today we're going to focus on simplifying expressions that have rational exponents. So previously we took a look at how can you convert back and forth between rational exponents and radicals. We talked about the connection that those two things have. Now we're going to move fully into how can we use the properties to simplify things with rational exponents. Now, if you need a brush up on just exponents in general, this table is going to help you. And if you remember, way back at the beginning of this chapter, we did a little pre-notes, those 6-0 notes. That may be another good thing to brush up on if you feel like you need some help, just basic properties. Because all the basic properties we did with whole number exponents are still going to apply even when we're dealing with rational exponents. So there's kind of two steps to take with this. First, you're going to convert everything to rational exponents, okay? You don't want any radical expressions when you're using these properties, okay? All the properties we're discussing are exponents, not radicals, so you do want to make sure that you know how to do those conversions for me, okay? Turn everything into its rational exponent form, and then simplify using rules of exponents in the table that I already pointed out to you. Now, as you probably know, every type of problem has its own slight nuances, okay? And sometimes there's even multiple ways you can do it. What I'm going to show you is I'm going to show you what I think is the easiest method to do it, but sometimes you may see another one, okay? So just know that some of these do have multiple ways to go about doing it. I'm going to show you what I hope is the easiest for you to understand and remember. So the first thing to remember is when you're multiplying two things together, that is going to mean that you can add the exponents, okay? So for this one, a to the 1/2 times a to the 3/4. Okay, remember that means all you have to do is add those exponents together to get your new exponent. Now, the neat thing is on the calculator can actually help you with that. Okay, so if you go to your calculator and you need to add 1/2 plus 3/4, you can actually do that on the calculator, okay? Now notice it's always going to give you a decimal answer. So what you do want to remember when you're doing this is if you go into the math menu and hit 2 fraction, that's going to turn it into its lowest fraction for you, okay? So problems like that, again, super easy. As long as you just punch in the calculator, boom, it'll get you your answer. So you have a to the 5/4 power. All right, and that's it. Now, this next one is another multiplication problem. However, remember that right now they're in their radical form. We need to put them in their exponent form. So right here, what I'm seeing is square root of 3. So this is a square root. And remember, a square root is the same as a 1/2 power. Okay? And a fourth root is the same as a 1/4 power. Okay, so remember those conversions. Okay, whenever you have a root, just a blanket root, all that means is, oh, 1/2 or 1/4. Now I can apply that same property that we used in the first problem. Now all I have to do is in my calculator, I can take 1/2 plus 1/4. Then hopefully you know what that fraction is. But again, if you need a little bit of help to go into math, turn it into a fraction, boom, you have your answer. And your answer is going to be 3 to the 3/4 power. So multiplying rules, not that difficult, right? All you're doing is adding. So let's move on to dividing. So remember, when you're dividing, remember, that means you're going to subtract your exponents, okay? So in this next example, x to the 4/5 divided by x to the 2/3, remember that is a subtraction rule, okay? Division turns into subtraction. And once again, feel free, go into your calculator, okay? So I need 4/5, and I'm going to be taking away 2/3. You're going to get that. And now, of course, math frac. and you're going to get your new power. You're going to have a new power of 2/15. And just like the last one, so remember, when you have something that's in its radical form, remember you don't want to leave it that way. You need everything in its rational exponent form. So here, now this time there's already powers on the things, right? So remember, the power is the top of the fraction, the root is the bottom of the fraction. So that would be x to the 3/4. And then this one, again, the power goes on top, the root goes on the bottom. And that would be x to the 2/8. And then, of course, after you get that far, once you turn it into its rational exponent form, now we can go and we can subtract them. So 3/4 minus 2/8, we get 0.5. I'm not going to bother math fracking that because you should know that that is x to the 1/2. 0.5 is 1/2. So again, nothing too complicated yet, right? All it is being able to use your calculator, knowing when to add or subtract, and then being able to bounce back and forth between radical form and rational exponent form. Now, here's where we start diving into once it gets a little bit trickier, okay? Because when there's parentheses, remember you want to simplify first. And that's something kids often forget. They just want to dive in and get going. But remember, take a step back. You want to simplify first. So let's take a look at what that means. So in the first one, x squared divided by x to the -7, all to the 2/3 power. So here what you want to do is you want to clean up the inside of the parenthesis first. X squared divided by x to the -7. Well, we're dividing, which means that we're subtracting exponents. 2 minus a -7. Well, if you're subtracting a -7, really you're adding it. So what you're really getting is x to the 9. Okay, or again, because of that negative exponent, you could actually picture moving that negative exponent up. That's another way to envision why you're getting a 9 on top. Now here's a rule we haven't talked about yet. Power of a power. So remember, power of a power rule says to multiply. So in this instance, I have x to the 9 to the 2/3 power. A power of a power rule means I'm going to multiply those exponents together. So I'm going to take 9 and I'm going to multiply it by that 2/3. That's going to give me a new exponent of 6. So here in the end, I'm just going to have x to the 6th. The next one is another one that you can play around with simplifying first, okay? Whenever you see those parentheses, I'm going to see what can I reduce first? What can I simplify first? So I have x to the 5 divided by x squared. So remember, when you're dividing, it means that you subtract. So that's going to give me x to the 3. For my y's, y to the 10 divided by y to the 4, so 10 minus 4 leaves me 6. All right, so here, now after we've reduced or simplified the parentheses, now we start dealing with that fractional power, that 1/3. So let's start working with that. Now, I do want us to remember that a 1/3 power is the same as cube rooting, right? So when I look at this thing, when it comes to the 27, the cube root of 27, we should know by now is going to be the number 3. The cube root of the number 8 is going to be the number 2. So those are just using that property of we know what cube roots are, so that's what we're going to apply there. All right, so you actually cube root both of those numbers. And now for the variables, now we go back to rules of exponents. So x to the third, or x to the third to the 1/3 power. So power of a power means multiplying, okay? And I'll show you on the calculator, but I'm hoping you can pretty quickly see that 3 times 1/3 is just going to give you an exponent of 1, right? So the x is just going to be reduced to have, or to be x to the first, y to the 6 to the 1/3. Again, power of a power, you are multiplying. Well, again, I'll show you on the calculator, but hopefully you guys can recognize 6 divided by 3 is just going to give you a 2. So this is going to turn into a y squared. And then that is as simplified as we can get it. All right, so let's keep moving forward. Let's move into the next set. So remember negative exponents. Remember what that means. So that means that whatever you're dealing with is going to end up flipping location. All right, so let's take a look at how these are going to operate. So we're going to start with that 9. So with the 9, when it takes on that negative 1/2 power, for now, I'm just going to leave that alone, okay? We're going to talk about what that is going to do when the 9 takes on that negative exponent. X to the negative 4 to the negative 1/2 power. Power of a power, well, negative 4 times negative 1/2. That's going to become a positive 2. So the x is going to become an x squared. And the y, well, let's look at what happens to the y. Power of a power. So let's take a look at that. 6 times negative 1/2. That's going to give me a negative 3. So that's what happens when I apply my power throughout the parenthesis. Okay? So, but now if you notice, now I have some negative exponents, right? So with those negative exponents, what that's going to do is move those things down. So the 9 to the 1/2 moves down. Y to the 3, oh, I'm sorry, I miswrote that. The 9 to the 1/2 moves down, so it can have a positive exponent. And the y moves down, so it can have a positive exponent. The x is just fine as is. So that's what you have to do to clear up those negatives at the end of a problem. And then finally, 9 to the 1/2 power. Well, a 1/2 power is the same as a square root. So hopefully you can recognize that the 9 to the 1/2 is just going to become a 3. And then that is as simplified as you can go. So again, in this one, that's how you deal with your negative exponents. So let's look at the next one and deal with that. So here again, I have the whole parenthesis to a negative exponent, all right? So I'm going to apply that negative exponent everywhere. So for the 6, power of a power, so I'm going to multiply. So 6 times negative 1/3 is going to give me a negative 2. So I'm going to have x to the negative 2. I'm going to have 8 to the negative 1/3. We'll get back to that in a little bit. And then the y, power of a power again. So let's calculate that. Negative 3 times negative 1/3. It's going to give me a positive 1 exponent, okay? So the y is just going to sit like that. So now we have all these negative exponents that we need to clear up. So the 8 is going to move up to get a positive exponent. The x is going to move down to get a positive exponent, and the y is just going to stay as is. Okay, it doesn't have to change. So once I clear up all of that, now the final piece is at 8 to the 1/3. A 1/3 exponent is the same as a cube root. All right, and you know what the cube root of 8 is. The cube root of 8 is just 2. So I would want to simplify this down all the way to here. And then that'll be all. All right. So let's look at two others, okay? Just to make sure, again, that we're keeping familiar with all of these strategies, okay? So here I have a parenthesis to a negative exponent, but there's nothing in the parenthesis that I can clear up. So I'm just going to start working with it. So that exponent of negative 3/4 is going to latch on to the 16, and then power of a power, y to the negative 8 to the negative 3/4 power. I'm going to multiply those together. So negative 8 times negative 3/4, that's going to give me a 6 for my new power. So again, all I had to do there was power of a power. I see that 16, its exponent is negative. So I'm going to move it down. So I have a y to the 6, but the 16, to make its exponent positive, has to go like that. All right? All right, so now 16 to the 3/4 power. So we need to deal with that thing now, okay? So remember, the top is the exponent, the bottom is the root, okay? So we need to remember that philosophy. So basically what that 16 is 16 to the 3rd power, and we're taking the 4th root of that, okay? Remember me stepping through that, me showing you that? So let's take a look at 16 to the 3rd power. Well, 16 to the 3rd power is going to be that. And now the 4th root. So remember, the 4th root is that generic root right there. 4096. And that's actually just going to give us the number 8. All right, so here that is just going to reduce down to this. And finally, our next one. So here again, we don't want radical expressions. We need everything to be in its fractional form. So the first thing I'm going to do is I'm going to call that y to the 1/4. Oh, then I almost wrote that wrong. To the 3/2. All right, so when I apply that exponent everywhere, I'm going to get a 9 to the 3/2, x to the 3/2, and then the y is a power of a power, 1/4 times 3/2. So I'm going to type that in the calculator. 1/2, or sorry, 1/4 times 3/2, and math frac that. That's going to give me 3/8. All right, now that 9 to the 3/2 power, okay? That 9 to the 3/2 power, remember, means that we have the square root of 2 and a power of 9. So here I'm going to show you a little bit different order. So this is more like the order I showed you in the last notes. So I'm going to square root the 9 first and then apply that power. So that's going to give me 3 cubed or 27. And you'll get that as your final answer. So I want to go back to this example right here. Okay, so notice as I was simplifying that, I did it in a slightly different order than I showed you in the previous notes, but ultimately got me to the same place. Okay, now let me show you why. So here, let's say I wanted to do the root piece first and then deal with the power. Well, now the fourth root of 16, you can look on your chart, is just 2. Exponent of 3, 2 to the third, still gives me that same 8. So the order you do those two things doesn't really matter, but probably I'd say this method is easier because you're dealing with smaller numbers along the way. All right, so a lot of good stuff in here, right? A lot of good notes. So make sure that you take the time, go write that summary. Make sure that you kind of reflect on what are you going to do to help you remember the differences in these and all the hints that I gave you, and then just come back ready for class, ready to do your practice work.